Alright, time for the DraftPhysics.com video presentation. Tired. Anyway, so I did a few more lever experiments. I was playing a little bit more with the coupled oscillator, and not a huge amount of progress, except it's not bad as an experiment, but I have to increase the frame rate. So either I have to use better lighting, or I have to use a better camera, or I have to increase the distance they move, or something. I have to reduce the velocity, reduce the weights, which I really don't want to do. So I have to consider what the best approach is. But this is close. I mean, it looks close. Let me just put it that way. But again, when you're doing frame rate, you're doing 2.5 versus 3 for a certain distance, and the velocity decreases rather rapidly because of the gravity thing. So it's not an ideal circumstance. I thought I would have a better capacity to get very good frames, and they're really, frankly, blurry and not so good. They're not going to be good enough. So I have to get it better somehow. So I was thinking maybe using one of Brozo's techniques of sound, and trying to measure the time difference between when they hit some kind of fixed distance. But then the fixed distance gets complicated because the lever isn't always perfectly straight. So lots of things to consider. So I'll play this, and then there's a link to this raw video if you want to look at it and analyze it. Yeah, so, not there quite yet. But it's close. I mean, it's close. So you can see distance-wise, you'll see that the two pretty, they reach similar heights. Similar. Not quite, but similar. I'm trying to get my finger on there, but I'm trying to get the lever straight. Not quite. So you can see we start about there, and this one's not going to land perfectly straight. But, it's pretty good. But obviously you can see it's got a lot of losses in it because it doesn't continue very long. So obviously it's not perfect. So this was a long way, so this one should almost go off the screen. So let's see if it does that. Well, see, that one's about, there was a ½ inch hanging over, and this one had like an inch hanging over, so it's not a complete conversion, but it's closer than the other experiments. Now the other problem is this is not a very thick steel, and I can see it does bend a little, so it's really not going to handle the 2 mass very well. But we'll see. So I'm above the line again, and this one's not falling very straight. Yeah, so that's a real failure. But you can see how subtle it is. I mean, you really do have to wait until everything works just right, and then you get a good result, and then you have to wait for another good result. So ½ inch or so, by my viewing, way short. Okay, so that wasn't as good as I thought it would have been. So, yeah, I guess it looked better when I was doing it than it looks better than it does in the video. But it's closer, that's all I'm going to argue. So this first one was really crooked. Yeah, very crooked. So I think this second one is probably one of the best ones. Let me see. I fiddle with the fulcrum a little bit. And so considering that this one does start from a longer distance away, you can see it is starting from a further this way. So it shouldn't go as far because it's going a longer distance. So I guess if you recognize that flaw, it's a lot closer than, so that one's like this line here. So I guess I'll leave the mouse there. So it started about there. And yeah, so, we're talking, it's still an inch or so behind. So whatever that would add up to, 80%, something like that. So really not quite good enough. But I'll continue to work on it. I'm really interested in catapults right now, and I'm just looking. So if anybody can find a serious catapult video, one where they just analyze the law of the lever or something and explain, as you go further out as you lengthen the catapult, it's basically a lever, and the law of the lever happens. You get twice the velocity with the lighter object. But I can't find any good. They're all kids videos. They're all just throwing pumpkins or some other kind of crap. No real good physics. What's the physics of the catapult? It all has to do with the angle you release at. And we're really after is when you release horizontally. And what's the velocity implications? I mean, that's what I'm after. Because, of course, I do believe it's the law of the lever. Twice the distance, twice the speed. If it's the mass is half, it's the same weight. So, yeah, works fine. So that's what I'm tending to think I need to prove. Although Bro's already sort of proved it, I think it needs to be done again just to prove the point. I also did mess with some clay experiments. So I did it a little different. And it was way too sloppy. I mean, I didn't even bother videoing it because, it takes 6 tries before I get one good result. So I obviously have to find a better way to do it, but the idea was kind of simple. So I guess I'll throw that into this lever video, even though it's not the lever subject. I'm thinking of building the spring, so we'll do that first, the spring-driven lever, and I really don't have to worry about doing the whole lever. So I'm thinking just even rubber bands or something, all right, to create a pressure. So when you swing the lever up, it stretches rubber bands, you get a consistent force, and then do the 2 mass versus the 1 mass at twice the distance, and see what kind of velocities you can acquire, okay, by propelling them with the same force on this side. So the same force on this side, and to see if it does their predicted 1.4 thing, when obviously I think it's going to do the 2 velocity thing, and nothing's going to stop it from being twice the velocity. And so it takes these problems out of the picture. Now the problem is, if I use the pendulum thing, then we still have the problem of getting the actual velocity as quickly as possible. So I guess I would have to set up a fixed distance for them to travel, so the distance has to be precise, and have some sort of bell that they hit or something, and then I can use sound to tell how fast they're going. Something like that. I mean, so I have to engineer something. Again, this should be done with people that have high-speed cameras and all this technology. These should be doing these experiments. And it's a sad tragedy that even my adversaries can't chime in or jump on that bandwagon. The bandwagon requesting better science videos, more elemental science experimental videos done well and precisely. The fact that you people won't even agree that they shouldn't be wasting high-speed cameras on, blowing up balloons. They should be doing something better with the technology. And the fact that you can't chime in and say, yes, we really need to get the lab physicists, the experimentalists, to do these elemental experiments, because they really haven't been done. I mean, we still don't have a decisive answer, something as simple as a Newton's cradle. I mean, their theory says I swing this half mass into this 3 mass, okay, and I get 150 momentum, so to speak. I get 150% of the energy I started with. That's their theory. That we should be able to know whether that happens or not. Obviously, I say it doesn't happen, of course. No chance. Now, there is some slow motion-ish, pretty well, let's not say it's some decent frame rate video of this experiment, and I think I probably should be able to analyze it. I just haven't gotten around to it. But it'll show that it's not 150% of this momentum. It's not going whatever 3/5 of the velocity or whatever the number would be. Anyway, so what was I going to talk about? Oh yeah, the other thing was the coupled oscillator. Yeah, there's just so many different experiments you could do, and none of them have been done. None of them. So you have the simple idea of the two mass here, and so I have it hanging from, I'm just curious, if somebody wants to do the math, 88 inches, okay, so I have two masses hanging from the 88 inches, okay, a one mass and a two mass, and what I'd like to figure out, I'd like to figure out the distance of this arc. What's the math for figuring out how? I'd like to do the distance rather than the height. The height is harder to measure than the distance. So ideally, I'd like to just do what's the formula for detecting how far you have to go to hit that arc, where your distance is 4 times this distance. This gets kind of complicated. Anyway, which, I don't, I don't like it being too complicated. But anyway, let's get back to this thing. So I had before had this hooked up to a lever. So this is fixed now. Fixed position here, some 21 inches between them. And all I had to do was put some rubber bands, okay, and put a weight here in the center. And it does couple. So fairly well. I mean, obviously it has to be initialized right, or both of them just swing. So once it's initialized, where this one's not moving and this one is, it stays that way for quite a while until it really starts to lose energy. And so basically it'll go 2 swings, and gain its full velocity, and you can see it's going much faster. And then a third swing, it stops this one, and then this one starts to move, and 2 swings later it's at its full arc, and then it switches back to this one. So it's like every 3 swings it switches from the energy being here to the energy being here, and then back and forth. So that is interesting, because I don't see too many examples of it demonstrated with uneven masses, and that seems kind of unfortunate, because again, this is another demonstration where you can say there's no other place for the energy to be except in this object or in this object. You initialize the system with one amount of force, and the force has to either be here or here, in a sense. It's either going to have a peak velocity on this side, or it's going to have no velocity over here, or vice versa. There's no other choices besides this one having a partial velocity and this one a partial velocity. So there's going to be a point where this one has 0 and this one has all of the velocity, and then it'll switch to the other side, this one having all of the force. And you can see in their action what all of the force means. For the lighter object, it's twice the velocity, I would guess. And for this one, it's half that velocity. Proving momentum is conserved, not kinetic energy. Alright, anyway, so lots of stuff to work on. And, I'm of mixed feelings. It's just kind of discouraging, because, like I said, if I don't have a way to detect the velocities, all of this is a lot of, really accurately. It is all kind of for naught, to just get a mediocre result. It's not much fun. Let's just put it that way. As much fun. So, the clay thing, I meant to describe that. So the clay experiment, I thought of, just because I happen to have these pendulums and all this stuff, so why not try to use it? And And again, it's really, the tricky part is making sure you get the angle, the height right. Okay, so the height in gravity has to be, 4:1. Okay, and so preliminarily, okay. So what I did was I have these, the twice mass and the half mass, and I just put a little thin rod on them, and then plowed that into the clay, and just measure how deep the rod goes into the clay. And what I'm finding is that it's pretty close to the same for the half mass. 4 times the height is pretty much the same penetration into the clay, the Play-Doh, so far. So it's sort of interesting. I also wanted to redo the Gosling video, but just trying to find ways of doing it better and all that kind of crap, and I haven't really thought of something better. I mean, except for putting a hole in the clay itself and then having the rod through the clay. So at least you're really eliminating any defects that could happen as you drop the weight onto the clay. Any turning or any other kind of crap. But who knows? Like I said, I think maybe just poking it might be the better solution. But we'll see. So just more stuff to work on. And I will say on the lever argument, I'll replay what physicist Michael's prediction was, but it seems like his prediction is wrong. I'm clearly getting a lot more than half the velocity on the other side. So when the one mass hits in the, two mass to two mass or one mass to one mass, I'm clearly getting very close to 80 or 85% of the energy's going into one object, and I would argue that very little energy is left in the other one, and there's no subtracting crap. The reflecting energy is the energy missing from the projectile moving. So if I want to know how much I'm losing, I can just look at the other side and say how much is reflecting. I'll probably find it, most of it there. Now again, some of it's being lost in the flex of the lever, and that's another problem. Alright, so so I try to keep this video short-ish, and I'll take care of other crappy arguments people are making. It's just so bad. There's no point even, it's just, there's a point where there's no point, because they're so off the subject. You go to the trouble to make these 5-minute videos where you're making the assertion, explaining the situation, one nice little isolated thing, and they just can't stay on that subject. And, pretend they can, well, I don't even want to, just won't even go into it, but it's just so, it's as disconnected as when you say, look, show me it taking 4 times the fuel to go twice as fast, and then they start showing you braking distance statistics that don't even match, by the way. Which is like Brozo, who he makes claims that he has debunked something because, well, I found it to be 10% off your prediction. Yeah, it's 150% off mine, but yours is off 10%. It's that bad. Like he's saying he somehow proved it takes 4 times the fuel, when all he proved is it takes more than 2 times the fuel to go twice as fast. It takes a little more than 2. So because it takes a little more than 2, it means it takes 4. It's so bad. So illogical. Such absolute nonsense. But anyway, we'll go into that in another video. So, just the update. I can't say I'm losing enthusiasm, but yeah, it's just like I said, why should these experiments be done this way? Tying a lever to a sledgehammer, blah, blah. Why? It shouldn't have to be done this way. Fuck. It's just so, this is crazy. Stupid is what it is. It's just stupid. It's stupid that you people can't admit that these experiments should be done well and precisely with good equipment, where you can verify things by different methods and be sure that the result is what it looks like. Anyway, till the next time and such.